Welcome to the tutorial. Today, we will explore the fascinating world of pathfinding algorithms in 3D space. By the end of this video, you will understand the core concepts behind pathfinding algorithms and be able to implement them in your own 3D projects. Pathfinding is a critical component in game development and robotics, as it allows agents to navigate through complex environments. We will focus on two popular algorithms, A** and Dijkstra's algorithm. Before diving into the code, let's set up our environment. We'll be using Java and a basic 3D engine for our demonstration. Make sure you have Java installed and a simple 3D library such as JavaFX set up. To begin, we need to define our 3D grid. In this case, we will create a simple 3D grid representation of our environment, where we can mark obstacles and free spaces. Let's create a grid class. Now that we have a basic 3D grid, we can proceed to implement the A** pathfinding algorithm. A** is efficient and widely used, combining the benefits of both Dijkstra's algorithm and heuristics. Let's create a class called node to represent each position in our grid that we will traverse. Each node will contain information about its position, cost values, and references to adjacent nodes. Next, we will implement our A** algorithm method. This method will take the start and end coordinates and return a list of nodes representing the path. In the A** implementation, we maintain a priority queue to keep track of nodes we need to explore. We also use a closed set to track nodes we've already evaluated. Now, we need to define the distance and heuristic methods. Now, we should implement a method to get neighboring nodes for our grid. Neighbors will be the adjacent nodes in 3D space. We will consider a 3 by 3 by 3 cube around each node. We will also need a method to reconstruct the path once we reach the destination. This method will trace back from the end node to the start node using the parent properties. That's it. We have successfully implemented the A** pathfinding algorithm in 3D. Now, let's test our implementation. We will create an instance of our grid, set some obstacles, and visualize the path found by the algorithm. Now that we've implemented and tested the A** algorithm, let's briefly explore Dijkstra's algorithm, which works similarly but doesn't use heuristics. We'll modify our previous code accordingly. Using Dijkstra's algorithm is straightforward as we just remove the heuristics from our node cost calculations. Implementing and using it is nearly identical to the A** method. While Dijkstra guarantees finding the shortest path, it can be less efficient than A** in large grids. In summary, you've learned how to implement both A** and Dijkstra's pathfinding algorithms in a 3D space using Java. These foundational algorithms are crucial for building intelligent agents in gaming and robotics. Before we wrap up, I encourage you to experiment with different grid sizes, obstacle layouts, and even consider implementing more advanced algorithms like bidirectional A** or jump point search. Thank you for watching. If you found this tutorial helpful, please hit the like button, subscribe, and leave any questions or comments below. Happy coding!